Welcome to day 144 of 365 days of Cookie Clicker. So, we have not had too much success with the super combos lately, but we will hopefully be breaking that streak today. Start by exploding some dudes. Pledge to the elders. Turn on the chime. And we are going to sit here. I just realized something. When you close the game and your magic is not maximized, if the magic is down here somewhere, when you reopen your game, the magic will have not refilled. That is super annoying. Oh, I didn't know that. I knew the garden was in stasis. I didn't know that would happen. Well, we've all learned something new. Let's take a look. We have a funky sugar lump. What kind of lump is it? It's meaty, which means it might get some extra stuff. We'll see. So, what we are hoping for is a good combination. Of course, because of my silliness, I can't fully take advantage of it yet with a spell. But we're going to do what we can. And we're going to see if we can't get some natural luck. So, we've got the frenzy. And we are hoping that we can get something else. I mean, if things are good enough, we could do the thing, but it seems so silly to do that without at least giving another chance. I mean, of course, we could sell wizard towers to get this number low, because it's 10 magic plus 60%. So, selling wizard towers is an option that we have. Just throw that out there. So, we'll see what we decide. We'll give it a few good old clicks. See if we can't get some mojo going. We could do a random season. Oh, I probably should mention, I don't know if I mentioned this last time or if it was even true last time, but I have now finally got all the Easter cookies. Where's Easter? Here it is. So, since I got all of them, I got an upgrade that makes permanently the Easter cookies will appear faster in the future. So, I am super happy about that. They call me the happiness guy. Yep. So happy that I could be my own smiley face. Right? Let's see. Yeah, this is lucky. I'm out of here. I'm out of here. Just kidding. I'm back. Okay. So, we'll see what we have going on here. We really soon will have this fully filled out. It will take a couple more minutes, but we'll have it. We'll have the mojo to do what we need to do. So we are hoping for some magic. Alright, what's our magic today? Another frenzy. Alright. Let's look around on the floor. Oh, there we go. Now, what happened was I left my apple juice container down here, and it's always important to have your apple juice when you play a video game, especially one like Cookie Clicker. It's a very apple juice. It's an apple juice related game, you could say. In fact, my next game, like as if I have a single game I've ever made, but if I were to make a game, it would be Apple Juice Tycoon 2000. It would be an idle game, but it would also be a tycoon game, kind of like the old school like Roller Coaster Tycoon. So it would be both of those things at once, but it would also be a platformer. And there would also be a strategy element. You know, attack and defense. My game would be all of those things. So, just throwing that out there, that would be my next game, and it's going to be amazing and good and wonderful. So, what we're going to do is have a sip of this apple juice. You can taste the orchard. Oh, spicy. Is this enough to want to do a thing? We're going to do it. We'll see if it's worth it. Where are you? Where in the hell are you? Okay. Oh, and it's lucky after all that. Oh, well. Well, make the most of what we got. Flick like a fiend. Yeah, Dragon Harvest actually is quite strong. Because it gives you 17. It's like a super advanced version of the Frenzy, and also forgot to do that. Now that makes a big difference because we don't have crap. What's that? Shimmer Lily? We've got plenty of those. Do we have... Did I hear the chime, or am I imagining things? I imagine I'm imagining things. Well, we'll hang out, and there should be another ring-a-ling happening soon. Ooh. This would have been an even better time to try that thing. You see this? It's just like everything is kind of going like a little bit sideways, where we get almost good stuff, but it's not that great. It's alright though. Figure it out. Oh, let's see. I like how much faster it goes when you flick. which should go without saying. I mean, it's called cookie clicker, but a lot of it is just idling. But it does go faster when you click. So maybe it should be called, well, it is called cookie clicker. What am I saying? Yeah. Alright. So, we've had some success. Not really, but we've had some kind of cool things. What we're going to do is we're going to take an investigative look on what happens when you buy Ultimate Butter Popcorn from your local Giant. Or Stop and Shop if you have those near you. It's the same thing. Now, if you have... Here's the thing about this. The serving time size is 2 tablespoons, but they also show 1 cup. And the problem with that being, well, the problem with that being is like, why are you not measuring it by the bag? You look at the bag, and what does it say the bag is? The bag has a sell-by date. Does that say 2023? I think it does. I'm going to show this to you. Yeah, you see that? I think this is no good. Yeah. Anyway, we're just going to put that back. But, okay. You look down here, and it says 3.3 ounce, 94 gram microwave bags. So you look over here, and we're on tablespoons, but then you have the hint 33 grams, right? 33 grams, but each bag is 94 grams, which is roughly three times the serving size. So what are they doing here? What are they doing? So anyway, it's about 450 calories for one of these bags. It's actually a fairly high calorie snack as they come. But that's good. Good to know. Now my question is, you see they make Duracell batteries, right? And, you know, what do batteries do? They give you energy. That's the point. They energize. The thing is, calories are also a measure of energy, right? Technically it's a measure of heat, I imagine, or heat potential or something like that, but that's just another way of saying energy. So there has to be a conversion between batteries and calories. That has to be so, but it doesn't say so on the battery. And I think that's something that they should rectify. There should be a calorie serving on the batteries. Because just like, it's good to know. Information like this is important to know. But you can't always trust that everyone's going to feel the same way. People have particular feelings about things. Now, if you look at, for instance, a bag of Lay's potato chips and their serving size, it says about 11 chips, right? Which, yeah, that's fair. It's like really your own fault if you eat more than that. But 11 chips, fine. 160 calories. So you're telling me that a bag of popcorn is worth 33 chips in calories. My problem with that is you reach into this bag and you find it's like you have some chips that are this size, right? Then you have some chips that are like really big. Like for instance, this guy, he's a bit of a chonker. But then you also get like really big guys. Like, look at this fellow. It's like, which one of these is it referring to? Or if you're unlucky, you might get like a small guy. Like, this guy is not too big. Like, what the hell? Does anyone even care? Is anyone even checking this stuff? I feel like no one's checking. Could be anything, you know? Now, It doesn't list the amount of calories on a bottle of water, but you would think it's not any. And it probably isn't. But then again, doesn't water give you energy? Now, what I'm referring to is, imagine it's like you have a mill, right? Like an old-fashioned mill. The water runs down the stream, goes on the wheel, turns the wheel, runs the mill. That's energy. You can say, yes, but that's not chemical energy. That's, it has to do with gravity and stuff. But still, the energy is stored in some way in the water. So wouldn't that be calories? Isn't that so? Also, say you put that water in a location where it's colder than that water. That water is going to give off heat to the rest of the environment around it. Wouldn't that be calories? I think it would be. I think that has to be taken into account. So it's like all these things. But also, you heat the water up. Let's say you microwave this for some reason. That's adding calories, right? That's adding heat. That's adding energy. You take the water out, it has more calories than it did before. You can't tell me it's zero, because it's not zero, it's more. So these are what we are dealing with here. These are the kind of thoughts that people are not having. And that's why I'm here, to bring these thoughts forward. Man, someone's got to say it. All right. So yeah, I don't think we're getting anything lucky this time. But, what can you do? But I say we go a little bit longer than regular, because we're going to have this back to normal soon. We are also going to have this back in play. A lot of things we can do. A lot of chances. At least, I like to think so. I bet a person has a lot of calories. Like, if you were to grill a human, you would go to jail. But you would also receive calories. In jail, as jail food. They should make a gimmick restaurant. And I'll pet a dragon before I explain the gimmick restaurant. Nothing? Okay. But yeah, in this gimmick restaurant, they serve prison rations. Like, exactly the same way that they do in a prison. And that should be like a thing. It could be all like prison themed and stuff. Like, and if you have like kids who are misbehaving and your kids are little troublemakers, it's like, if you're good, we'll go to the nice restaurant. If you're bad, we'll go to the prison restaurant and you'll eat prison food. I think that would be a good motivator. So then you'd go there and there'd be a bunch of crying kids, and that would be a very popular ambiance to have. It's like, no, mommy, daddy, why bring me to this place? It's like, well, you were bad, so you get prison food. I don't know. Maybe that wouldn't be ideal. But, I don't know, people like gimmicks. People like gimmicks in their cooking. Yeah, novelty restaurants would be the way to be. Oh. something else they should do is like there should be a mode in this game where it shows you not just the cookies you've made, but how many calories you've added. Because like your average chocolate chip cookie, like what they're showing you, there's a knowable amount of calories in there, right? So you go over to the stats and you see how many cookies we've cooked all time. And yeah, it's a big number. So you take that number, multiply it by how many how many calories are in a cookie, and you get yourself how many calories you've made. And since I'm still pretty sure a calorie is a measure of heat, you can compare that to real world things. Like you can compare that to a supernova. How many calories are in a supernova? That is something that is measured and known. I bet you we've made many supernovas worth of calories at this stage. How many calories was the Big Bang? That's probably knowable within like a certain range, like upper bound, lower bound. And I want to know if we've made a Big Bang of calories yet, just from cookies. These are all things that could be known, and like to figure out the what would be needed in order to do that. Like how many realistically, because like you have to have all the elements in play. You know, you need the chocolate, you need the flour, and you need the milk and everything. Like, in order to have all those resources, how many planets will you need, like Earth-like planets, to grow all that? And then you have to consider that, like, an Earth-like planet can only form because, you know, we have an iron-rich crust and mantle and probably a liquid iron core, and iron can only be formed by intense nuclear fusion at the core of a very massive star. So how many stars would you need of adequate size to make enough iron to make enough Earth-like planets? And then you get into, yeah, how many massive stars will you need? How do those stars form? Where does that matter come from? And then you go all the way back from there. You know, it's, well, who was it? Carl Sagan, who said, if you want to build an apple pie from scratch, you first have to invent the universe. Well, we are hypothecating a universe here that is capable of generating everything needed to have all these cookies. And also, I guess we should keep in mind the industrial capacity to bake the cookies, you know. We need fuel sources for the ovens that we're going to have. And we're going to need the labor, and we're going to need the infrastructure for that labor. You know, not just housing, but also just the very matter that makes up not just their body, but also the food chain under them that allows them to exist, and the atmosphere and the planet beneath their feet that allows them to exist. So we're going to need all that infrastructure, and there's probably a ratio, like, we're going to hypothecate they're humans because we don't know who or what else could make cookies. So we would hypothecate the humans to a certain degree. How many humans per cookie, or how many cookies per human, would, in an ideal situation, where you take an average human and you educate them in the most efficient way to make cookies, but then you have to like keep in mind like work-life balance and everything, because you can't just be a slave driver. His productivity is going to stop. And even though we're hypothecating, we want the humans to have a good life. So they're going to have nice union jobs in the cookie factories making these cookies, but they're going to have an adequate life outside of work too. So we're going to have to hypothecate the resources it will take for that to be a thing. And then we're going to hypothecate how many people it will take at that kind of pay scale and at that kind of standard of living to make these cookies. Take that into account into our energetic calculations. And of course, we have heavy materials in our body. We have iron in our blood, for instance. So you have to take that into account when building out the stars and, you know, the conditions that created those stars in the universe. So those are all things that you would have to conclude, and you can add all that together and use your calorific calculation to figure out how many calories that is, and then figure out from there what you would need to generate all that, like how much heat, how much energy is the physical universe even capable. Do we have to stretch some physical laws? Do we have to get into quantum? Do we have to get into string theory? All these things out there. It's not entirely known. I think that there's been probably inadequate research done in these ways, because usually people are interested in practical applications, and once you get above a certain level of cookies, it becomes really impractical to even consider what that might look like. But I think it's an adequate thing to do, because, like, as a mental exercise, it's not necessarily even about the mental results, like the results of what you think about. It's like the mental lattice, the mental scaffolding you create in order to come up with these ideas. Well, not just the ideas, but to come up with the solutions to these ideas. That mental scaffolding can have practical applications. So I think this is the kind of thing that should be teaching in schools. They should be teaching how to solve problems like this, because while they might seem frivolous on the surface, that mental scaffolding will enable them to solve much more realistic problems, because there's always various problems that come about in this world, and you can't always prepare for each of them. Like, if you try, one of my great flaws is, like, I try to have a script ready for any kind of problem that comes up, right? But there are so many different slight variations of things that makes this script completely useless. So what you have to do is have generalized principles that you can then use and generate your response from that. So you sort of have, it's sort of like a fractal, like a decision fractal that comes out, and you can sort of understand how to generate the next step of the fractal each way. Rather, it's like a generalized rule rather than knowing what to do at each juncture, because that quickly devolves into chaos, and when you're trying to solve problems that way, you might as well just do random things and just hope that it works out, because it's not going to be any easier for you. So you have to plan this out in terms of having a general principles that just sort of branch out and create a fractal of decision making. There might be some precision lost, but by and large, I think would be a better way of thinking, and I think that is the way that you get these results that we need. But of course, then you have to take into account the social situation of people coming at it with different points of view, different life experiences, and they have their different ways of thinking and their different blind sides, and it all has its root in brain chemistry and also their personal history. And then there's also like ego clashes that people will have with one another, where no one's going to be pure of intention about just like solving the problem. They're going to also want, oh, look at me, puff up their chest and all that. So you're going to have to take that into account. So it's going to be more of a social situation at that stage. You're going to need to get into social theories of, are we going to have a more, how are we going to organize this? And it's at this point that things get really murky, because when we're dealing with social sciences, we're not dealing with the hard sciences of biology or chemistry or physics. We are dealing with humans, with people, and how they interact with each other, and that's a very complicated thing. I mean, it all works on physical laws, but the human brain is so complex. It is so complex that we cannot scientifically model what's going to happen. We can only sort of intuit what's going to go on, and we can only do that because we have a massive amount of data and history, just because, well, there have been billions of humans alive on this earth, and these humans have been with one another in various configurations over the years, and that's resulted in plenty of data. But yet, being able to analyze all that data and use it in a useful way is beyond what I think that many of us can do. And I'm losing my patience, so we're just gonna do this and get out of here. So, yeah, this day has been resistant to anything good happening, but we're done. So, thank you for watching, and we'll see you tomorrow.